Find the exact value of all 6 trigonometric functions evaluated at 2 times theta if the cosecant of theta is minus 3 over 2 and theta itself is in quadrant 3. Well, I'm thinking this is a great opportunity to use our double angle formulas. I know the sine of 2 theta is equal to 2 times the sine of theta times cosine theta. And the cosine of 2 theta is equal to cosine squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 times cosine squared theta minus 1. And after I know sine and cosine, well, I'll just use other trig identities I know to find the rest, because I know tangent is a sine over a cosine. After I have sine, cosine, and tangent, I'll just take reciprocals to find cotangent, cosecant, and secant. All right, but I'm actually going to start by drawing a triangle, because I know cosecant theta, I actually need to know sine and cosine. Well, I like drawing reference triangles with reference angles in there and ignoring the signs on these. And so cosecant, well, I like to think about sine first. Sine is the opposite over the hypotenuse, so this must be the hypotenuse over the opposite. And so I have a 3 over 2 there. Again, ignoring that minus sign because I know my angle's in quadrant 3, and so I'll get my signs correct here in a moment. All right, so I'm missing the adjacent side, so I know that 9 is equal to 4 plus a squared, so it looks to me like a is going to have to be the square root of 5. This will let me write down sine theta and cosine theta. Sine theta has to be minus 2/3, and I guess I already really knew that if I just took that reciprocal. And then in quadrant 3, cosine's also negative, so that's going to be minus root 5 over 3. All right, the sine of 2 theta, 2 times the sine of theta, minus 2 over 3, times the cosine of theta, minus root 5 over 3. So let's see, that's going to give me a positive 4 root 5 over 9. I found the sine of 2 theta. I need to pick one of my double angle formula identities for cosine to use, and since the closest thing to given information I have to use is that, I'm going to use this middle identity. 1 minus 2 sine squared theta. All right, so 1 minus 2 times minus 2 over 3 squared. All right, well, that's going to be 1 minus 2 times 4 ninths. 1 minus 8 ninths is 1 ninth. Now I'm ready to find the rest of my trig functions evaluated at 2 times theta. So I just need to divide those. I'll get 4 root 5, making cotangent of 2 theta 1 over 4 root 5. Cosecant of 2 theta is going to have to be 9. And then secant, excuse me, folks, the secant of 2 theta is equal to 9. And the cosecant of 2 theta is equal to 9 over 4 root 5. And so I found all 6 trig functions evaluated at 2 times theta. And just by looking at these values, you can actually determine what quadrant that double angle has to end up in. And I'll leave that for you to think about.